Okay, next up, let's review some right triangle trigonometry, SOH CAH TOA. And what this is supposed to help us memorize is the three right triangle trig ratios. So is sine of our angle equals the opposite over the hypotenuse, O over H, opposite over hypotenuse. Cosine of our angle equals the adjacent, so that's the A, over the hypotenuse, which is the H. So there's our CAH. Cosine of our angle is the adjacent side over the hypotenuse. And tangent, our third trig ratio, is equal to the opposite over the adjacent. Tangent of our angle is the opposite side over the adjacent side. Okay, so the first thing you want to do when you're solving one of these is pick one of your two acute angles, so not the right angle, but one of the other two, and we would label this as our angle of reference, called the reference angle. Okay, and we use that to label the three sides as the opposite, adjacent, and hypotenuse. So the side opposite is either across from our angle or it's the only side that angle does not touch. The hypotenuse is always opposite the right angle, and it's always the biggest length in our right triangle. And adjacent just means next to. So in other words, this is the side that's next to our angle, but not the hypotenuse. Okay, so let's use that to set up the first one for A. Find our missing length x. So note that we have a right triangle. So first thing I'm thinking is maybe Pythagorean theorem. However, I don't know 2 out of the 3 sides. I don't have enough information for Pythagorean theorem. So next I would think maybe I can use my special right triangles. But with a 47-degree angle, it's not a special right triangle. And so here's where I would know, okay, now I need to use SOH CAH TOA, or right triangle trig. So they've given me one of the 2 smaller angles, and even though you could solve for the missing one, remember these 3 add up to 180, you don't need to. Let's just use the angle they've given us. So that's my reference angle, and we need to label our 3 sides. So for me, I like to label the opposite first. So opposite my angle would be x. Oops, so this is the opposite side. 12 is the hypotenuse, right? It's across from my right angle. So hypotenuse is over there. And then this side is the adjacent. Okay, now if you have like all of these pieces of information or more than just these 2, you can kind of pick your own. But here, we're going to go ahead and say which one is not very helpful for us in this problem, or not important. Well, we know the hypotenuse. That gives me a number. That sounds important. And we're solving for the opposite, right, which is x. So these are the 2 that are important to us for this problem, the opposite and hypotenuse. So now I think SOH CAH TOA. Which one involves the opposite and hypotenuse, SOH, CAH, or TOA? In this case, that's SOH. And what that means is that sine is the trig function we want to use this time to solve for our angle. And as we set this up, we say sine of the angle theta equals, of our angle equals the opposite over the hypotenuse. Okay, so here we're going to go ahead and fill in our angle. Our angle is 47 degrees. Equals the opposite side, which is x, over the hypotenuse, which is 12. And I always suggest this, that to make your life easier when it's not as simple as this particular one, if you set this up at being over 1 and cross multiply, so kind of treat it like a proportion problem. X times 1 is x equals 12 times the sine of 47 degrees. Okay, now the sine of 47 degrees is a decimal value that we can get from our calculator. We'll learn later on where that comes from, but for now, we just need to use a calculator. So here's where we bring in, say, Desmos. Okay, so important, first, there's a little switch here. Make sure that you're in degrees, so you can see DEG. Otherwise, you're in the angle measuring unit radians, which we'll talk about again. So degrees, and I want to do 12 times, and you'll actually see sine, cosine, and tangent right here, which is great, sine of 47. And as long as this is in degree mode, it knows that means degrees. And this is the length of my missing side, 8.776, etc. So it says round to the nearest hundredth. So that's 2 decimals, but remember we'll need to look at 1 and more to figure out how to round. So here we need to round up. 8.78. 8.78 is our approximate missing length. And that seems reasonable based on my figure, right? We already know the hypotenuse, which should be slightly smaller, and it seems pretty reasonable. Okay, if you get an answer like 112 in this figure, I'd hope you'd go, that doesn't sound reasonable. Okay, B though. Let's try another one. So here, again, they've given me one of my 2 angles. Or I guess if I went through my checklist, I can't use Pythagorean theorem because I don't know 2 out of the 3 sides. It's not a special right triangle, so now I'm thinking right triangle trig, SOH CAH TOA. So here's my angle of reference. Let's label our sides. This side is the side opposite, so that would be our 5. The blank one over here is the hypotenuse because that's opposite my right angle. And down here would be the adjacent side, where x is. So this time, the one that doesn't really help us very much is the hypotenuse. So I'm thinking the 2 I'm interested in are the opposite, which I know, and the adjacent, which I'm solving for. So A and O, or O and A. So I'm thinking SOH CAH TOA. Which one uses A and O, or O and A? TOA, which means tangent. So this time, tangent's the trig function that will help me figure this out. So, oops, I will start with sine. So tangent of our angle, theta, equals the opposite over the adjacent. So filling that in, we can say the tangent of 20 degrees, that's our angle, equals the opposite side, which is 5, over the adjacent side, which is x. And here's where some students run into problems, and this is where I say, if you cross-multiply, make this a fraction, and cross-multiply, we're going to end up with x times the tangent of 20 equals 1 times 5, or 5. And to get x by itself, well, tangent of 20 is held with multiplication. We just divide both sides by tangent of 20 degrees. So in fact, to get my answer, I need to do 5 divided by the tangent of 20 degrees. And I need to do that in my calculator, or Desmos. Okay, so we'll bring that back in. Here's our calculator. So I'm going to delete that 5 divided by, and again, it's always good to make sure it's in degrees, since we're using degree. Now you can actually type in tangent, I think. I'm just going to go ahead and click this anyway. And we'll type in 20 and 5 divided by the tangent of 20. Again, we're going to go to 2 decimal places. So we'll need to round up once again. 13.74. X is about 13.74 units of length. Okay, so this is how we can use SOH CAH TOA to help us find missing side lengths if we can't use Pythagorean theorem and can't use special right triangles, and it's a right triangle. SOH CAH TOA, or right triangle trig, will help. Now we can also use this to find missing angles. Now note here, I do know 2 sides, so if we really wanted to, we could find the 3rd side with Pythagorean theorem, but we're not asked to find a missing side, we're asked to find the missing angle. And so here's where these trig ratios will help us again, but we're also going to need to use what's called the inverse sine, or inverse cosine, or inverse tangent. And we saw this inverse notation, right? Like f inverse of x, right? Meaning inverse, that -1. So that is inverse notation. Now these are also sometimes called the arc sine, arc cosine, and arc tangent. They mean exactly the same thing as inverse. So anyway, just so you're exposed to those a little bit. But let's use this to find my angle. We've been given an angle. Let's mark that as our angle of reference and label our sides. This is the opposite side. 24 would be the hypotenuse. And the blank over here is the adjacent side. Because it's blank, I'm figuring that's not really going to be very helpful. We can just get rid of that one. So I'm thinking the two most helpful we know are the hypotenuse and opposite. Now, by the way, if you did know all three sides, that's okay. Just pick two. Pick your favorite two, and that will tell you which trig to use. Just pick one. Anyway, here, O and H goes along with sine. We need to use sine again. Sorry, cosine. So here we're using SO or sine. So the sine of our missing angle, theta, equals the opposite, which is 9, over the hypotenuse, which is 24. So this is from our SO, right? Sine is the opposite, sine equals the opposite over hypotenuse. Okay, now note that our angle is locked inside this sine function. Well, how do we get to cancel out sine? We need an inverse sine. And so guess what we're going to do to both sides of the equation? We're going to take the inverse sine of both sides. So that would look like this. We take the inverse sine of theta and the inverse sine of 9/24. So here, the inverse sine and sine cancel each other out. And we're just left with theta degrees is equal to the inverse sine of the fraction 9/24. So the inverse, when we're using inverse sine in the calculator, we're telling it, we're giving you a ratio and we want the angle. So again, we'll go to, say, Desmos. Now to get to the inverse ones, they're not on the main page. You need to go to functions. Go to functions, and then you'll see inverse sine, cosine, and tangent, or arc sine, arc cosine, arc tangent. So here we're going to do the inverse sine of 9 divided by 24. And this ratio, by the way, sine can never be bigger than 1. So you probably saw it said undefined until I wrote 24. So this value always has to be less than 1 for sine, or equal to 1. So 9/24 gives me an angle, and we're going to round to the nearest tenth. And in this case, that means I will not need to round up. We're going to write 22.0 degrees. About 22.0 degrees. Now, the reason we're leaving that extra 0 there is to let anyone know that we did go to the accuracy of the tenths place, but that we didn't need to round that to a different digit than 0. Okay. And by the way, now that I know one of these, I could find the other by subtracting from 90, right? If that's about 22 degrees, this would be, what's 78, right? 78 degrees. Subtracting from 90. Anyway, because these three should add up to 180. All right, let's move on to the next one. Our last one here, we've got a reference angle. We're labeling our sides. We got the opposite. We got the adjacent. And we got this hypotenuse, which does not seem very helpful. So see you later, hypotenuse. Opposite and adjacent means tangent again. Man, sorry, cosine. All right, so TOA, the tangent of our angle in degrees equals the opposite over the adjacent, 12/5. Just like before, we would do the inverse tangent of both sides. Okay, so we get theta is equal to the inverse tangent of 12/5. So once again, we go to Desmos, we type this in, inverse tangent of 12 divided by 5, and we get that our missing angle, going to the nearest tenth or 1 decimal for angles, is 67.4 degrees, about 67.4 degrees. Okay. So obviously we'll go over more questions about this in class, or go over more examples in class. But important things. These are all things that you should have learned. I know that last year was a little bit weird, but these are all things you should have learned in geometry last year before you left. So they are a little bit of a review. Thank you guys. We'll do some in class. See you next time.